Welcome to Barker's Random Projects. Today, we're going to show you how we built a Christmas light show using ARGB lights and how we did something that at least we've never seen before, letting the audience help pick the next show to play. How we ended up deciding to make a light show is a bit of a long story, so it suffices to say we started down one path and ended up on another, which in this case turned out fine because our objective was to make something cool for our kids and the neighborhood kids to enjoy. This time we made sure to follow the engineering process, and if you're wondering why I'm mentioning that, check out our automatic Halloween candy dispenser video to see why. We started with a lot of research into how people make Christmas light shows, and the options out there. Everything from what lights to use, how to power the lights, what software to use, and how to transmit a radio signal so people can listen to the songs in their car. It was kind of overwhelming at first, so we decided to establish a criteria of what we'd like the show to look like. We used this, along with the limitations of time and cost, like a funnel, to help us narrow down the options. We really wanted to be able to change the color of the lights. This led us to decide on the ARGB lights, which stands for Addressable Red, Green, Blue Light. The specific strand we used can be found in the description below. The unique thing about the lights we picked is that they only have 3 wires coming from a strand, instead of 4. One for positive, one for negative, and one for a data line. To show how ARGB lights work, we will represent the data sent to the lights as this stack of cards. Each of these boxes represents a single light on the ARGB strand. Each light takes one card off the stack, then passes the stack to the next light. This card represents the color the light should be. This process allows each light to be controlled individually, unlike a regular red, green, blue light strand, or RGB for short. That is why the data line we mentioned earlier is so important. In the case of a regular RGB strand, it would be like the entire strand received only one card to tell what color to be. The regular strand has 4 wires instead of 3, a ground wire, and 1 wire for each color. The card the strand receives contains data to tell each wire how much power it will receive, and thus how bright each color, the red, green, and blue, will be. The combination of these colors creates the final color that we see. In the ARGB lights, this happens in each individual light instead of the entire strand, making the effects options with ARGB lights far superior. Once we knew the lights we wanted to use, the next thing was to find a way to control them. The cheapest and coolest route we found was using a little Wi-Fi microcontroller called a D1 Mini, which can be found for a few dollars each. We installed, or flashed, software onto it so that it could control the ARGB lights. The software we used was called WLED, which later, because of limitations, we changed to a software called ES Pixel Stick. Now that we knew what was possible, we could start laying out what we wanted our light show to look like and finding a way to make a light show that went to music. To map the lights to music, we decided to use the open source software called X-Lights. The first step, after reading and watching lots of tutorials on how to use it, is to make a layout in the program that represents how all the lights will be set up in your yard. Then, the lights can be grouped and assigned names to simplify making the show. With the layout done, you can select a song and make a show. I had always wondered if there was a program that would simply analyze the song and make a show to go with it, and there may be something out there that does that, but I had to add each feature to the show one at a time. I did find a plugin for X-Lights called the Queen Mary Vamp plugin from the University of London. Very helpful. The plugin can analyze a song and provide a variety of markers that indicate beats, bars, keys, tempo, etc. Then you can use these to place the light features so they change with the music. Once you have the show done, it's time to integrate with the hardware. The basics of the hardware is a computer to send data to the lights controller, which will in turn tell the lights what to do, and a power supply that transforms the power from your outlet, the 120 AC, to the 5V DC that the lights and controller run on. The controllers and lights don't always run on the same voltage, but it's more convenient when they do, so that was something we looked for when we were selecting our hardware. After making a frame and doing a lot of soldering, we had our lights up and were ready to start testing our shows. It took some adjustments along with troubleshooting to get everything up and running. One example of troubleshooting is when we plugged in the lights for our center structure, we noticed that they were lagging when we played the song. First, we tested to make sure our strand was good by plugging in one of the other strands. Then, we tried testing the controller by switching it with one that was already working. We found these changes made no difference, so we decided to do some research. We found that the WLED software has a bug in it that prevents it from running more than 300 to 400 lights, which was really frustrating since we needed to control double that amount. Luckily, the bug report that told us about this also recommended using the software ES Pixel Stick. Once we flashed that software onto the controller, our problem was solved. So our advice is that if you try this on your own, expect some setbacks and be patient. The The last thing we added to our show was an FM transmitter. This would allow us to broadcast the songs so people watching the show can listen to the music on the radio. Now that we had it running, we wanted to free up our computer, so we decided to copy the songs and upload it to a Raspberry Pi and use software called Falcon Player to run the light show. Not that kind of Pi. A Raspberry Pi is an inexpensive, credit card-sized computer that can be used to run simple programs. The Falcon Player is an open source program that allows us to make a playlist and schedules so that it can run continuously without us needing to do anything. And that was great, but we got thinking of how when we go to other shows, we have to wait for the songs to cycle through, and sometimes kids aren't so patient waiting for their favorite song to come back around. So we decided to make it so people could use their phones to vote online for what song played next. Then we thought, why not share the love and make it so anyone using Falcon Player could use this feature? But how could we do that?
Well, the Falcon Player allows custom plugins to be installed, so I developed a plugin that would run in the background which controls what song plays. When the plugin runs, it takes a list of song names in the desired light show and then uploads them to the voting website with a unique identifier. The unique identifier is key to making sure that when the other people install the plugin and enable voting for their own light shows, the show doesn't interfere with each other. The unique identifier is key to making sure that when other people install the plugin and enable voting for their own light show, the shows don't interfere with each other. This way, you only see the songs they listed and your votes only affect what is being played at their house. Identifiers are used all over the internet. You can think of an identifier as the barcode on the back of your favorite cereal box. That code is used by the store to track various things about it, such as how much it costs or tracking how many boxes they still have in stock. The plugin works by waiting until a song is getting close to ending. Then it will ask the voting website what song had the most votes and play that song. If there is a tie, one of the songs that was tied for the most votes will be played at random. The neat thing about the voting website is when someone votes for a song, everyone who is looking at the website will instantly see the number of votes for that song increase. We currently haven't added a way to prevent multiple votes from one person, but found this to be an added way to have fun, as it allows you to race each other to see who can push the vote button for their song the most times. Thanks for watching. Please subscribe and consider donating to help us keep making cool stuff.